Think about what happens when you sit down at your desk to type. You reach out, press a single key on your keyboard, and you don't even have to think about it. The very second your finger pushes down, that exact letter pops up right there on your monitor. It feels instant. In computer science, this action is called input. It is the first major job of any computer system, accepting the commands and data that you, the user, give it. Seeing that letter appear almost feels like magic, but behind the scenes, there is a massive invisible translation happening in the blink of an eye. A computer isn't doing magic. It is simply an incredibly fast translator, taking your physical tap on a piece of plastic and turning it into a visual result you can understand. The big hurdle here is a language barrier. The electronic brain inside your machine doesn't actually speak English. It has no idea what an A or a B is. Under the hood, the only thing your computer truly understands is the physical flow of electricity. And electricity running through a circuit really only has two possible states. It is either flowing, which we call on, or it is stopped, which we call off. Early computers literally relied on human operators standing in giant rooms, manually routing that electricity by plugging in cables and flipping physical switches. So to get your human letter onto the screen, that keystroke has to be translated into this incredibly basic, machine-level language of simple on and off commands. Imagine a single light switch. We call this single switch 1 bit of data. It can only hold a value of 1, meaning on, or 0, meaning off. If you only have one switch, you only have two options. That is nowhere near enough combinations to spell out the entire alphabet, numbers, and punctuation marks. To solve this, we group these switches together. If we line up a sequence of 8 of them side by side, we get what is called 8-bit. By flipping these 8 switches into all their different combinations of on and off, you suddenly have 256 unique mathematical patterns to work with. When you press a key on your keyboard, you are sending a pulse of electricity that locks those 8 tiny invisible switches into one specific pattern perfectly assigned to that letter. So 8-bit is the core vocabulary your computer uses. It takes human input and turns it into physical patterns of electricity the machine can hold on to. Once that pattern is created, it travels to the processor, which acts as the central brain of your computer. The processor's entire job is data manipulation. It reads your pattern, applies a set of logical rules to it, and figures out exactly what it needs to do next. And it does this at a speed that is hard for the human brain to even picture, easily chewing through millions of these instruction patterns every single second. We used to process data by physically sliding beads on a wooden abacus, one by one. Now, all of that calculation happens automatically in microscopic circuitry. The processor finishes its lightning-fast calculation and generates a brand new 8-bit pattern. This new pattern is the machine's answer. That is all processing really means. It takes your input pattern, applies logic instantly, and prepares a new pattern to send back out. Now we reach the final phase. The computer has its new pattern, but it needs to translate that data back into something our human eyes can understand, the output. If you look microscopically close at your computer monitor, you'll see it isn't completely smooth. It is actually a vast, hard-edged grid. This grid is made up of distinct little squares called pixels, and they are the basic visual building blocks of every digital display. Zoom in further, and you'll see a single pixel is actually a cluster of 3 microscopic lights, one red, one green, and one blue. By adjusting the individual brightness of these lights up and down, it mixes them to produce almost any color. Your screen is actually just a massive, incredibly dense array of individual programmable light bulbs, all waiting in the dark to receive their instructions. This is where everything comes together. The processor fires its newly calculated 8-bit instructions directly to this massive grid of pixels. Those instructions act as precise commands. They tell very specific pixels exactly which colors to turn on and which to leave off. Suddenly, thousands of these tiny squares react to the instructions in a coordinated wave, flooding the screen with light. That precise pattern of illumination creates the exact visual shape of the letter you originally typed. From keyboard to screen, every computer task is just the input, process, and output of billions of microscopic light switches, all dancing in perfect harmony.